Okay, here we are in the back side, worksheet number 7 for unit 10. The ones you should like are like number 11. That's a difference of perfect squares. And those are the types I'm not as concerned about because you guys have been doing a pretty good job with those. So basically set them up in your two parentheses. If you have a difference of perfect squares, you're always going to have a plus and a minus. So the square root of 9 is 3. I put that in the back end. And the square root of 25w squared is 5w. Now, those go on the front end. You can do your outside and your inside, and the thing about these is that the outside, negative 15y, inside, positive 15y, they cancel. So we don't have a middle term. That's why there's only two terms when we started, and it actually all works out really nice. Now, you always want to see if there's a GCF first, but with 25 and 9, there wasn't. Same with 49 and 64. Only factors of 49 are 7 and 7. Other than 1 and 49, they don't go into 64. So this is going to be, number 12, another straight up plus, minus. A difference of perfect squares here would be 7p in the first slots. And then 64, the square root is 8. So I have 7p plus 8, 7p minus 8, and I've got the right answer. You can always FOIL to check. Now the problem with these and the hard part is that you do not want to forget one very important thing. Ready for it? Do not forget the GCF. Now, there was no GCF for 11 and 12, but then all of a sudden you get to 13 and you might think those aren't perfect squares, or I can't do this problem. You can if you take a GCF out first. There's a 10 that comes out, and on the inside that would be m squared minus 1. Well, look at that. Once you take a GCF out, you see that there's a difference of perfect squares right there in the inside. Square root of 1 is 1, so that's an easy square root. So we do 10, and then we just split up the m squared minus 1 with m plus 1, and then m minus 1. Sorry, m minus 1 there. So realize that this is, with my highlighter here, you're just taking this right here, and you're splitting it up into m plus 1, m minus 1. You took the 10 out, you leave the 10 along for the ride, but the final answer to this problem is the entire factored version 10 times m plus 1, m minus 1. All right, little extension on number 14. It is a difference of perfect squares without a GCF. So what you're going to do is, again, you're going to go like this. You're going to go, hey, I need a plus, and then I need a minus. Well, the square root of 16 is 4, so no worries there. But the square root of x to the fourth is actually x squared, and then x squared. So if you did that, fantastic. But here's the deal. If we look at this, this one right here is another difference of perfect squares. That's not, because it's a plus sign here, so we can't do anything with that. But actually, we can just keep it along for the ride. So this is going to be x squared plus 4. And then this is a difference of perfect squares, which that one breaks up into x plus 2, x minus 2. And to be very clear, like this right here is the one that broke up into the x plus 2, x minus 2. This one just stayed along for the ride. The final answer is this whole thing there. That was an extension one. I do hope you understand that, but it's a little bit more complicated. All right, look in here. Solve these by factoring first. So here's the deal. I have one side equal to 0. So real important notes. You have to have one side equal to 0 to do these problems. So I have that here. So then I look for my GCF. So if you're getting comfy with this, that means there's going to be a 30x you can take out. So 30x times x plus 2 equals 0. That's just taking a GCF out. Now we've said in class many times, if you have something times something equal to 0, one of those two things has to be 0. So I take this one, and this is where the split happens. Either 30x equals 0 or x plus 2 equals 0. And then now I just solve each of these. Divide by 30 to both sides, and I get x equals 0. Over here, subtract 2 from both sides, and I get x equals negative 2. So x equals 0 or x equals negative 2, two possible answers. All right, following those guidelines, we are supposed to get one side equal to 0 first. I did. Then I look for a GCF. There is none. Now I notice that I'm going to factor. I'm going to get something times something equal to 0. But the thing is here is that it's going to be trinomial factoring, not GCF factoring. So something times something equals 0, I just go through all my hints. Minus sign right here means plus and minus. X in the first slot, X in the first slot. Factors of 4 that get me to 3, I can actually kind of think about this and know that a -4, and a +1 are going to be those two factors there. I can FOIL this to make sure I'm right, but I am right here. And then I have something times something equals 0, so one of those two things has to be 0. So x plus 1 equals 0, which ends up being -1, or x minus 4, this pen is getting crazy on me here, sorry, equals 0. So add 4 to both sides and we get x equals 4. So two possible answers are +4 and -1. All right, don't get thrown off by the little thing here on number 17. This hint I have here will not be there on your test. So realize one side must equal 0. So I'm going to make this 14x squared minus 28x equal to 0. That's the first thing I do. I'm not showing my work here, but I'm taking this and I'm subtracting 28x from both sides. They're not like terms, so they stay here, but now the right side's 0. Now I have something just like number 15. If you look back at number 15, a GCF problem. So I'm going to take a 14x out. And that leaves me with x minus 2 there on the inside, equal to 0. And here it is, guys. I've got something, different color here. I've got something times something equal to 0. So one of those two things have to be 0. So 14x equals 0, or x minus 2 equals 0. And then when I solve each of these, divide by 14, I'm going to get x equals 0. Add 2 to both sides on that one, I'm going to get x equals 2. All right, last problem. You ask, what do we do first? I will tell you again, you must get one side equal to 0. So I'm going to add 11x to both sides. Now here's the kicker. 0 will be on the right, but on the left side, I want that to say 2x squared, and then I actually want to say plus 11x, and then plus 5 equal to 0. Because I want it to be in this form that I'm used to for factoring. Well, there's no GCF, so we're going to try this again. Hopefully you see the 2x squared is going to lead me to have a 2x and an x. My signs are both going to be positive for this problem. And then the factors of 5 are going to be 5 and 1. Now, let's be honest, I'm getting pretty good at factoring after teaching it now for 10 years. But it may take you a little bit longer to come up with that factoring. Just keep guessing and checking until you hit the one that foils out correctly. But here we are, we have something times something equal to 0. So we do our split. So 2x plus 1 could be 0, or x plus 5 could be 0. Well, on this one, it's pretty straightforward. We're just going to subtract 5 from both sides, and that one answer will be -5. This one actually takes 2 steps. If I subtract 1, I have 2x equal to -1. And then I got to divide by 2. So I'm actually going to get x equal to -1/2 here, and -5 for my other answer. Okay? I hope this helped. Watch any videos that you need more practice on, but please remember the GCF tomorrow. Okay? This needs to be in your brain. This needs to be you thinking of this tomorrow as you take your test. Thank you.